Hi, it's anterior rami. This is the second part of the development of central nervous system. So in this video, we want to look at the development of the brain, which is the cranial part of the neural tube. You know, when we have the complete formation of the neural tube around day 25 and day 27, when the neural pore closes up, this is how it looks like. This is the development of the brain. This development of the neural tube, rather, so this is the neural tube. So within the neural tube, there's a particular structure we call the what? Neuroepithelial cells. So this is the cranial part of the neural tube, and this is the caudal part of the neural tube. I've explained this in my previous video where I talked about the neural pore closing up at their respective period of time. Do you get? So when we have the complete formation of the neural tube, this is how it looks like, the neural tube. So in this video, we want to lay emphasis on the cranial part of the neural tube. You know, in my last video, there's something I talked about, the congenital anomalies that are associated with the neural tube if the neural pore didn't close at its normal closure period. You know, there's something called maternal serum screening. You get? So the serum of the mother can be used to screen for congenital anomaly. If the maternal serum contains elevated fetoprotein and acetylcholine esterase, that denotes that the neural tube is prone to have defect. You get? So that is about that. So let us look at the cranial part of the neural tube. Now, around this cranial part of the neural tube, there's something we want to look at. We call it vesiculation. Vesiculation. What do we understand by the word vesiculation? Vesicles. Vesiculation is the process involved in the formation of brain vesicles. Do you get? Brain vesicles are just like a bulge, a dilation, a swelling of the cranial part of the neural tube. You see this lateral end of the cranial tube, they begin to bulge, they begin to become dilated and form a bulge-like fissures, and that is what we call the brain vesicles. In the cranial part of the neural tube, there is a particular cells that proliferate, causing this cranial part of the neural tube to bulge. And what is the name of those cells? The neuroepithelial cells, which are situated within the neural tube. So as they become proliferated, the cranial part of the neural tube begins to bulge, forming a dilatation around the end of third week and the beginning of fourth week to form the vesicles, which is the brain vesicle, because it is this brain vesicle that will later become our future adult brain. Now, the first brain vesicles to be formed, it is what we call the primary brain vesicles. The primary brain vesicles is formed around the third and the fourth week. Yes, around the end of third week and the beginning of fourth week, immediately after the formation of the neural tube. So how is the primary brain vesicle formed? The neuroepithelial cell proliferates, causing this edge to dilate, to swell, to bulge. And the primary brain vesicle that is formed are 3 in number. So these are the brain vesicles here. We have it to be like this. Okay. This is the brain vesicles. Yes, so these are the 3 primary brain vesicles which are formed during the third or fourth week of development. This brain vesicle here is what we call the prosencephalon. Prosencephalon. This one is what we call mesencephalon. Mesencephalon. While this one is what we call rhombencephalon. Rhombencephalon. Yeah, so these are the 3 primary brain vesicles that are formed during the third or fourth week as a result of proliferation of cells the new epithelial cells that are present around the cranial part of the neural tube. What are the three brain vessels? Prosencephalon, mesencephalon, and rubencephalon. Then what happens as the new epithelial cell continue to proliferate? Do you get it now? As they begin to proliferate continuously, around the 5th week of development, then the prosencephalon also divides and bulge to form some brain vesicles. We also call it the secondary brain vesicles. Now, what are the secondary brain vesicles? These are the secondary brain vesicles. So, we call it the secondary, okay? The secondary brain vesicles, which are formed during the what? 5th week of development. The secondary brain vesicles arise from the primary brain vesicles around the 5th week. And what are the secondary brain vesicles? We have it to be 5 in number. 2, 3, 4, 5, and the. So these are the 5 secondary brain vesicles. And what are they? The prosencephalon will give rise to these 2 brain vesicles. And what is the name of these 2 brain vesicles? This is what we call the telencephalon. Telencephalon. This one will give rise to the diencephalon. The telencephalon and the diencephalon come from where? From the prosencephalon. While the mesencephalon will also remain as the what? Mesencephalon. Can you see the brain vesicles? And the rubencephalon, around the 5th week, we also divide into 2, which is the metencephalon and the myelencephalon. Myelencephalon. So these are the 5 brain vesicles that are formed. Around the 14th to 23rd week of gestation, these secondary brain vesicles begin to give rise to the future adult brain. Do you get? Now, let's look at the telencephalon, what it will become in the future adult brain. The telencephalon will give rise to the cerebral cortex. I'm talking about the future adult brain. It will give rise to the cerebral cortex. It is the telencephalon that will also give rise to the hippocampus. Yeah, hippocampus. It will also form the what? Basal ganglia. The basal ganglia, it will also give rise to the what? Amygdala. Amygdala. Yeah, so these are what the telencephalon give rise to in the future adult brain. We also have what we call the diencephalon. Let's look at what the diencephalon will give rise to. The diencephalon will give rise to the hypothalamus. It will give rise to the thalamus. It will give rise to the epithalamus. It will give rise to the metathalamus. It will give rise to the pineal gland. It will give rise to the neurohypophysis, optic nerve, and so on and so forth. That's what the diencephalon will give rise to. The mesencephalon will also give rise to the future adult brain, which is the what? Midbrain. Yeah. The midbrain comes from the what? Mesencephalon. And we also have the metencephalon. The metencephalon will give rise to the pons and cerebellum. Pons and cerebellum. Lastly, the myelencephalon. The myelencephalon will give rise to the what? Medulla oblongata. Medulla oblongata. Yes. So these are what the future adult brain comprises of, and they all come from the what? Secondary brain vesicles. So that is all about vesiculation, how the brain vesicles are being formed from the third or fourth week to the fifth week, then till the future adult brain around the 14th to 23rd week of gestation. The next thing I will explain is what we call ventriculation, the process involved in the formation of the ventricles of the brain. You know, within the lumen or space of the secondary brain vesicles, that is where the ventricles of the brain develops from. Are you getting what I'm saying now? The ventricles of the brain is also around that 23rd week of development, around that 14th to 23rd week. That's where we have the ventricles of the brain. And how is the ventricles of the brain formed? They are coming from the lumen or space cavity of the secondary brain vesicles. This space here will give rise to the ventricles of the brain. Now, the telencephalon, the space of the telencephalon will give rise to a particular ventricles of the brain. You know, when we talk about the ventricles are lined by some cells. We call it ependymal cells. So those cells assist the ventricles to produce and circulate the cerebrospinal fluid throughout the brain and spinal cord. That is the essence of the ventricles of the brain, for the production and circulation of CSF, cerebrospinal fluid, which helps to cushion the brain and the spinal cord. So the cavity of the telencephalon will give rise to a two ventricle. What do we call the ventricle? We call it lateral ventricle. So this is what we call the what? Lateral ventricle. They are two in number, two lateral ventricles. They all come from the telencephalon. Then there's a particular ventricle that is formed by the cavity of the diencephalon. This is the diencephalon. It goes like this. That ventricle is what we call the what? Third ventricle. So it is the cavity of the diencephalon that forms the third ventricle. The mesencephalon does not give rise to ventricle, but as a result of extension of the third ventricle into the mesencephalon, then the cavity of the mesencephalon gives rise to what? Cerebral aqueduct of Sylvius. Cerebral aqueduct of Sylvius, which is the cavity of the mesencephalon, the big brain. Then the metencephalon and the mesencephalon, their cavity will become what we call the what? Fourth ventricle. You get? Then what will form the what? Fourth ventricle. Now, in these ventricles of the brain, there's something that connects the two lateral ventricles with the third ventricle. This is it here. We call it what? We call it foramen of Mungo. Foramen of Mungo. Mungo foramina. It is also called interventricular foramina. It is the one that connects the two lateral ventricles with the third ventricle. There's something that also connects the third ventricle with the fourth ventricle, and that's what we call the what? The cerebral aqueduct of Sylvius. So that is about the ventricles of the brain. And you know, the fourth ventricle will continue into the spinal cord as the central canal of the spinal cord. So lastly, I'm going to explain what we call the brain flexure. Yes, brain flexure. The brain flexure. What do we understand by the brain flexure? If you don't forget, all these brain vesicles are developing within a space of the skull. We call it the cranial cavity. So the space at which all these brain vesicles are developing are limited. Do you get? So the limitation accounts for this brain vesicle to fold, to bend, and that folding action is what we call brain flexure. So the essence of the brain flexure is for the developing brain to occupy the limited space of the cranial cavity. And it is also essential to determine the shape of the brain, the crescent shape of the brain. That is the essence of the brain flexure. What are the three brain flexure we have? The three brain flexure are we have the cephalic flexure. We have the cephalic flexure. Yes. We also have the cervical flexure. And the last one, we have the what? Contd flexure. Flexure that will occur to the brain vesicle causing this vesicle to occupy the limited space of the cranial cavity. Now, the first flexure to be formed is the cephalic flexure, and it occurs immediately when there is formation of the primary brain vesicles. You know, this is the primary brain vesicles. You get, these are the primary brain vesicles. So we have it to be like this. This is the prosencephalon, this is the mesencephalon, and this is the what? Rhombencephalon, and this is the what? Spinal cord. Just the same thing with this. So how did the cephalic flexure occur? Cephalic flexure is the flexure, you know, this is the what? This is the prosencephalon, this is the mesencephalon, and this is the rhombencephalon. Cephalic flexure occur at the junction of the mesencephalon. That is why sometimes it is regarded as mesencephalic flexure. Now, what happens to the mesencephalon? Now, let's look at it. So, there's something that happens to the mesencephalon. This part of the mesencephalon, they fold and become something like this. This is the mesencephalon. So, the mesencephalon folds. And we have this, okay, let me use this to avoid confusion. And we have this, yes, so this is the prosencephalon now. Now this part is what we call the mesencephalon, and this is the rhombencephalon. Now can you see the bending action of the mesencephalon? So the mesencephalon fold, they bend so that they can occupy the limited space. So if you look at this junction of the mesencephalon, so the folding that occurs at this junction of the mesencephalon is what we call cephalic flexure. Now the cephalic flexure, there's something so important about it. It has a dorsal, you know, in embryology, anything above is dorsal, anything below is ventral. So it has a dorsal convexity and a ventral what? Concavity. That is one thing you need to know about the cephalic flexure. It has a dorsal convexity and a ventral concavity. The next flexure is the cervical flexure, the second flexure to be formed, which occur at the junction of the rhombencephalon and the spinal cord. We call it 90-degree flexure. How do we have the cervical flexure? So this is the cervical flexure here. This is the prosencephalon. This is the mesencephalon that has become flexed. Now, at the junction of this part here, at the junction of this rhombencephalon, it also flexed to become like this. Okay? It also flexed. It also flexed like this. Yes. So this part is what we call the prosencephalon. This part, there's a flexure here, cephalic flexure, which is the mesencephalon, which is the cephalic flexure. But there's also a flexure around this part. This flexure is what we call the what? Pontine flexure. This is the pontine flexure. Sorry, this is the cervical flexure. The cervical flexure occurs between the rhombencephalon and the spinal cord. It is a 90-degree. Can you see? It's like a 90-degree structure, a 90-degree flexure. It is just like the mesencephalic flexure. You get? It has a dorsal convexity and a ventral concavity. That is what you need to know about the cervical flexure. It occurs between the rhombencephalon and the spinal cord, 90 degrees. Then the last flexure that we like to explain is the pontine flexure. Pontine flexure occurs immediately when we have the formation of these 5 secondary brain vesicles. You get? So this is how the flexure looks like. You know, this is the prosencephalon. There's a flexure that occurs here. Okay, let me use this. There's a flexure that has already occurred here, which is the what? Cephalic flexure. Then when you know this is the prosencephalon, then this is the what? Mesencephalon. During the 5th week, what happens to the rhombencephalon? It will become the metencephalon and diencephalon. So around the 5th week, we cannot call this the prosencephalon again, because the prosencephalon has given rise to the telencephalon and diencephalon. So let's say this is now the what? Telencephalon. Do you get? And this is now the what? Diencephalon. So at the junction, this is the telencephalon. Yes, this is the telencephalon. This is the what? Diencephalon. So around the mesencephalon, there's already a flexure. This is what we call cephalic flexure. Then the metencephalon and the melencephalon, there's now a flexure that occurs in between these two, in between the metencephalon and melencephalon. That flexure is what we call the what? Pontine flexure. So this is how it goes. Yeah, to make it more evident, it comes like this and goes like this. Exactly. So this is the telencephalon, this is the what? Diencephalon. These two is what we call the what? Prosencephalon. Is that not true? Then at the junction of the mesencephalon, we have a flexure called what? Cephalic flexure. So in between the metencephalon, this is the metencephalon, and this is the melencephalon. In between these two is a flexure called what? Pontine flexure. Pontine flexure has a dorsal concavity and a ventral convexity, as opposed to the cephalic and cervical flexure. Now this is the last flexure here, which is the what? Cervical flexure, which occur at the junction of the two. You know, this two is what we call the rhobencephalon, because they come from the rhobencephalon. So at the junction of these two, which is the metencephalon and the melencephalon, with the spinal cord, there is now a flexure we call the what? Cervical flexure. So that is about the pterygic flexure. So the first flexure, cephalic, occur at the junction of the mesencephalon. The cervical occur at the junction of the rhombencephalon and the spinal cord. And the pontine flexure occur at the junction of the metencephalon and the melencephalon. Now we are done with this video, which is the development of the brain. As you can see, these are the critical structures of the brain and the brain itself. Now we are done with this video. Don't forget that at the end of this video, there's always a practice question that can give you more and pre-knowledge, and that can give you more insight about what development of brain is all about. Please